Hey everyone, today we are going to solve the Daily LeetCode challenge of 17th March 2024, and the problem statement is insert interval. So let us first understand the problem statement. So according to the problem statement, we have been given a 2D integer array nums such that it contains only positive integers and it is sorted in ascending order based on these first value of the vector. Okay, so you can see that we have 1 over here, then we have 3, we have 6, we have 8, we have 12, and they all are sorted in ascending order, correct? And they are non-overlapping. Fine. Now, what does these individual vectors represent? So each of these individual vector are an interval. Okay. Now, what is an interval? An interval basically has a start and an end. So you can think of this 6 as a start time and this 7 as an end time. Okay, so you can think of this as a start and this 7 as an end of that interval. Okay, similarly, if you will consider this interval 1, 2, so 1 is the start of the interval and 2 is the end of the interval. Okay, and what do I mean by non-overlapping? So say for example, if we have two intervals as 1, 2 and 2, 4. So you can see that this 2 is common to both of the intervals, right? So it means that they are overlapping. So instead of writing two intervals, we can simply merge them and write a single interval that is 1, 4. Okay. So you can notice that in this nums, we don't have any overlapping intervals, correct? So it means that all the intervals are non-overlapping. Additionally, we have been given a new interval such that this 4 represent the start and this 8 represent the end of the interval. Fine. And what we have to do is we have to insert this interval 4, 8 in nums such that after inserting this nums remains sorted in ascending order and there is no overlapping interval. Okay, so what do I mean? It means that once we have inserted this new interval in this nums should remain sorted in ascending order as it was earlier, and it should be non-overlapping. Okay, now before discussing how we are going to solve this problem, let's first see that what are the possible cases that we can have. Okay, so let's first discuss the case 1. So you can see that this is the nums given to us and this is the new interval. So let me first draw a number line. So this is the number line. Now let's plot these intervals over this number line. Okay. So the first interval is 1, 3. So it means we have 1, 2, 3. Okay. So let's. Now what is the next interval? The next interval is 5, 6. So we have 5 to 6. And after that, we have 9, 10. So we have 9 to 10. Correct? So these are the three intervals which was initially given to us in nums. And what is the new interval? The new interval is 7, 8. So where is it? So it's over here. Okay. So you can see that all these four intervals are having no common points, right? So it means that each of them are non-overlapping. So what would be our first case? Our first case would be each of them are non-overlapping. So it means that the new interval which we want to add to this nums is not overlapping to any of the interval present in nums, correct? So this would be our first case. Now, how are we going to check this? So we will simply iterate over nums. So say for example, if we are present at this element of nums and we will check that whether this last, that is whether this end of this interval is less than this 7 or not. If this end of the interval is less than the start of the new interval, so what does this mean? You can see that this 3 is less than 7. So it simply means that they won't have anything in common, right? Because say for example, this 1, 3 is something like this. This 1, 3 is from here to here, right? And this 7, 8 is from here to here. So you can see that this end is lesser than this end. So it's obvious that they won't have anything in common, correct? So until and unless the end of an interval is lesser than the start of the new interval, then what it means that these two intervals doesn't have anything in common. So what we will do, we will simply keep on adding this one to our result. Say for example, this is our result or this is our answer. So our answer will also be a 2D vector. Why? Because nums is a 2D vector. So after inserting this new interval to nums, we will get a 2D vector only, right? So since these two don't have anything in common, so what we'll do, we will simply insert 1, 3. Then we will move forward. So again, we will check that the end of this interval is 6 and the end of this interval is 7. So 6 is also less than 7, right? So you can also see that we have this 5, 6 over here and we have this 7 to 8 over here. So this 6 is lesser than this 7, correct? So they don't have anything in common. So what we'll do, we'll simply add this one also over here. Then we'll move to the next element. Now we'll check that whether this 10 is lesser than the 7. So we can see that 10 is not less than 7, correct? So where do we have this interval? We have this interval 9, 10 over here. So this 10 is greater than 7. So there is a possibility that these two intervals may have something in common, correct? So we will check whether these two intervals have something in common or not. Now, for these two intervals, that is the new interval and this current interval, to have something in common, what should have been the case? We should have this 9 less than equal to this 8. Then only they could have something in common. That is, then only they would be overlapping. Why? Because you can see that what we have 7 to 8 and we have 9 to 10 over here. If this 8 would have been greater than this 9, then only they would have something in common, correct? So we will check whether this 8 is greater than equal to this 9. So we will find out that this 8 is not greater than equal to this 9. So what does it mean? It means that these two are also non-overlapping. So what we will do? We will simply insert this one, this new interval, and we will also insert this current interval, correct? And now again, we will move forward. So we have completely exhausted all the elements of num. So what does it mean? It means that this is our resultant and this is the answer after inserting the new interval in nums, correct? So we are done with discussing the first case in which the new interval is not overlapping with any of the interval in nums, correct? Now let's discuss the second case. For the second case, we would be using the same 2D vector nums and the new interval would be 2, 5. So let's draw a number line again. So this is the number line. Now let's represent each of the interval of this nums in this number line. Okay, so first interval is 1, 3. So we will have 1 to 3. After that we have 5, 6. So we will have 5 to 6. Then we have 9, 10. So it would be 9 to 10 over here. Now let's represent the new interval over this number line. Okay, so we have 2, 5. So here we have 2 and here we have 5. Okay. So what we are noticing over here is here we have two intervals, correct? The first one is 1 to 3. We have this 1 to 3 and the next one is this 2 to 5. So you can clearly see that they are overlapping, right? So what would be our second case? Our second case would be overlapping and what we can see is that the new interval, this is the new interval, right? 2 to 5. So this new interval is overlapping with an existing interval that is 1 to 3. And additionally, once we look, we have 1 to 3 and then we have 2 to 5. So we can clearly see that this 2 is common in both of these interval, right? 1 to 3 means what? It means that we have 1, 2, 3 over here, correct? And this 2 is present in this interval as well as in this interval. So it means that both of them are overlapping, correct? Additionally, you can see that we have one more interval, 5 to 6. We have 5 to 6. So you can see that this 5 is also common, correct? So it means that this existing interval and this new interval are overlapping and additionally, this end of the new interval is also common to one of the existing interval, correct? So the second case would be overlapping and merging. Now, what does it mean by overlapping and merging? So let's first quickly do a dry run for this interval, then it would be easier to understand. So initially, we are present at the very first interval of this nums, that is 1, 3, and this is our new interval, right? And what we were checking in, like previously what we were checking, we are checking whether this 3 is less than this 2 or not. If this 3 is less than 2, then what does it mean? It means that they don't have anything in common. So let's check whether this 3 is less than 2. So 3 is not less than 2. So what does it mean? It means that these two intervals have something in common. Now for that, what are we going to check? Now let's check whether this 5 is greater than equal to this 1 or not. So we can see that 5 is greater than equal to 1, correct? So it means that both of these intervals have something in common. So what we have to do, if they have something in common, so we have to merge them together, right? Because what we want that after merging, we should have no overlapping interval, correct? So let's see how are we going to merge them. So the first interval is 1, 3 and the new interval is 2, 5, correct? So what would be the start of the interval? So let me represent this. Here we have 1 to 3, correct? And here we have 2 to 5. So what would be our new interval? Our new interval would be from this 1 to 5, correct? Then only we are going to cover all these. That is 1, 2, 3, 4, 5. Then only we are going to cover all these, correct? So how are we getting this 1? We are getting this 1 by finding the minimum of this 1 and 2. So what is the minimum of this 1, 2? So the minimum of 1, 2 is 1, correct? And how are we finding this end of the interval? We are finding this end of the interval by finding the max of 3, 5, correct? So what is the max of 3, 5? It's 5. So what would be our new interval? Our new interval would be 1, 5, correct? And why are we doing this? We are doing this because we want to cover all the elements in between them, right? In between both the intervals. Fine. So now we have merged these two intervals. So what we have to do, since we have merged these two intervals, so let's insert this in our answer, correct? Firstly, update our new interval, correct? So our new interval is not 2, 5 over here. Our new interval will become 1, 5. So we will have 1, 5 as the new interval. Now, what did I discuss? I discussed that we had this overlapping case over here, right? Now, after this overlapping case, we also have this merging case. And how is it there? So you can see that we have 5 to 6 as well, right? And this 5 to 6 is also having this 5 common to the new interval, correct? So we have to check for the cases that once we have merged the new interval with an existing interval, then is it possible that there exists some more intervals in nums that has something in common with the new interval, right? We have to check for that case as well. So we can see that if our current pointer will move over here, correct? So what do we have? We have 5, 6. We have 5, 6. So we can see that in this 5, 6, and in the new interval 1, 5, we can see that this 5 is common, correct? And how are we going to find whether it's common or not? We are going to check that whether this 5 is greater than equal to the 5, this 5. So we can see that the 5 of the new interval is greater than equal to the 5, this start of the current interval, correct? That is the end of the new interval is greater than equal to the start of the existing interval. So what does it mean? It means that they again have something in common. So they are also overlapping. So what we have to do is we have to merge them, right? And how are we going to merge them? Again, for finding the start, what are we going to do? We are going to find the minimum of 1, 5. So what would be the minimum of 1, 5? The minimum of 1, 5 would be 1. And for finding the end, what are we going to do? We are going to find the max of the ends. That is the max of 5, 6. So what would be the max of 5 and 6? The max would be 6. So what is the new interval? The new interval will now get updated to 1, 6. So we will have 1, 6 as the new interval. Additionally, you can see that what does it mean? It means from 1 to 6 is the new interval. And why are we doing this? We are doing this so as to cover all these elements of these intervals, correct? So this 1, 6 is our new interval. Now again we have to check that after merging, do we have any overlapping of this interval with this interval, correct? So when we'll compare this interval and this interval, so we can see that this 6 is less than 10. So it means that there is a possibility that they can have overlapping. So for them to be overlapping, what do we need to check? We need to check that the end of this interval, that is the end of the new interval, that is this 6, should be greater than equal to the start of the existing interval. So what is the start of the existing interval? It's 9. So we can see that 6 is not greater than equal to this 9, right? So it means that this 1, 6 does not fall somewhere in between this, right? It does not fall somewhere in between this. It means they don't have anything in common. So what we have to do, we will simply insert this new interval. So we will have 1, 6 over here, and we will insert this interval as well. So we will have 9, 10 over here. So this is our new answer. So what did we did? We firstly merged 1, 3 and 2, 5 because they had some elements in common. And after merging, what did we did? We got a new interval, that is 1, 5, and then we merged this 1, 5 with the existing interval 5, 6, and we got a new interval 1, 6. And this new interval 1, 6 didn't had anything in common with this existing interval. So what we did? We got 1, 6 and 9, 10 as our answer. Okay. So we are done with the second case. Now let's move over the third case. So for the third case, we will have the same nums array. Okay. And the new interval is 2, 4. So now let's represent all these interval over this number line. Correct. So the first interval is 1, 3. So we have 1, 2, 3. Okay. Now let's represent the second interval, that is 5, 6. So we have 5 to 6. Correct. And after that we have 9, 10. So we have 9 to 10. Correct. Now let's represent the new interval, that is 2, 4 over the number line. So we have 2 to 4. Correct. Now what we can see? We can see that this interval 1, 3 and this new interval 2, 4 are having some part in common, correct? So what does it mean? It means that they are overlapping. So what we will have in the third case is we will have only the overlapping case, correct? What we had in the second case? In the second case, the new interval was overlapping with an existing interval. Additionally, it was overlapping with some other existing interval as well, correct? So what we did in the previous example, we first merged the new interval with the existing interval, that is with 1, 3, and we got a new interval. And after that, we merged the new interval again with the existing interval 5, 6, correct? But in this example, what do we have? We don't have the overlapping part again and again. So we don't have to do the merging again and again. We have the overlapping part only once. So what we have to do? We have to merge the new interval in the existing intervals array only once, correct? So let's see what are we going to do. Currently our pointer would be here and this is our new interval. So what we will check? We'll check whether this 2 is less than 3. So we know that this 2 is less than 3. So what does it mean? It means that there is a possibility that this and this interval are overlapping, correct? So we have 1, 3 over here, that is the existing interval, and we have 2, 4 over here, which is the new interval, correct? So what we need to check? We need to check whether the end of the new interval, what is the end of the new interval? The end of the new interval is 4. Whether this end of the new interval is greater than equal to the start of the existing interval. So what is the start of this existing interval? The start of this existing interval is 1. So is this 4 greater than equal to 1? So we can see that this 4 is greater than equal to 1. So what does it mean? It means that the existing interval and the new interval are overlapping. So what do we have to do? We have to merge them. So how we merge them? We first take the starting of the new interval. So for taking the start of the new interval, what we do? We take the minimum of the start of both the intervals. So what would be the minimum of 1, 2? The minimum of 1, 2 would be 1. And for taking the end of the interval, what do? We take the max of this 3 and 4. So what would be the max of 3 and 4? The max of 3 and 4 would be 4. So what is our new interval? Our new interval is 1, 4. So we can also see that here we have 1 and here we have 4. So you can clearly see that we have covered all these elements of both the intervals, correct? So this would be our new interval. So what we will do? Say if this is our answer, we will insert 1, 4 in our answer. And we can clearly see that if we take this new interval, that is 1, 4, and if we are present at this current interval, so what we'll check? We'll check whether this 1 is less than the 6. So this 1 is less than this 6. So what does it mean? It means that there is a possibility that these two are overlapping. So let's check whether these two are overlapping or not. So what we have? We have 1, 4 and we have 5, 6. Okay. So this 1, 4 is our new interval. Our new interval will get updated to 1, 4. Correct. Why? Because we merged this 1, 3 and this 2, 4 and got a new interval 1, 4. Okay. Now this is our new interval and this is the existing interval. Now what we want to check? Now we want to check whether this 4, that is whether the end of the new interval is greater than equal to the start of the existing interval. So we can see that this 4 is not greater than equal to 5, right? So what does it mean? It means that the new interval and this existing interval doesn't has anything in common. So what we'll do? We will simply insert the new interval in answer and we will insert this 5, 6. And since this new interval doesn't has anything in common with this interval, so it is pretty obvious that it won't have anything in common with all the next intervals, right? So we will simply add 9, 10 as well. So this would be our answer. So what we discussed that in our first case, we were having no overlapping. What does it mean? It means that the new interval that we want to add does not overlap or does not have anything in common with any of the existing intervals of nums, correct? What did we discuss in the second case? We discussed that the new interval has some part or like has something in common with an interval of this nums, correct? So what does it mean? It means that this is overlapping with one of the existing interval, and after merging them we found out that the new interval that we got, it's again overlapping with another existing interval, correct? So now what did we discuss in the third case? In the third case we discussed that the new interval is overlapping with only one of the existing interval of this nums, correct? So this is all the three cases that could be possible. Now I hope it's clear to you all, and we are going to do the same thing while writing the code. So let's quickly code this. So we will start on by creating a 2D vector of integer. Let's say it's answer, and let's take a variable index as 0. Now, what do we have to do? We have to first check for the non-overlapping case. Okay. So when are we going to say that these two intervals, let's say if we consider this interval 1,3 and this interval 7,8. So when are we going to say that these two intervals are non-overlapping? We'll say that these two are non-overlapping until this 7 is greater than this 3, correct? That is until the start of the new interval is greater than the end of an existing interval, then only it means that they are not going to have anything in common, correct? So let's write this. So we will say that while this index is less than intervals dot size. Intervals dot size. So let's take this intervals dot size in another variable. Let's say n. So while index is less than n and n, intervals of index of 1 is less than new interval of 0. Now, what does it mean? It means that the end of an existing interval is less than the start of a new interval. It means that they have no overlapping, right? What does this mean? This means that no overlapping. So what we will do, we will simply insert the current interval in the answer, right? So what we'll do, we'll say that answer dot pushback intervals index. So we will push the existing interval, correct? And what we will do after that, we'll simply increment the index. So we will do index plus plus, correct? Now say for example, if we have found out that the new interval start is less than an existing interval's end, then what does it mean? It means that they have a possibility of having something in common. So it means that they can be overlapping. So what do we need to do to check for the overlapping case? Check for overlapping case. So we will write a while loop and we'll say while this index is less than n and then the intervals index of 0 is less than equal to the new intervals 1. So what does it mean? It means that what we are checking, say for example, this is the new interval and this is the existing interval. So what I am checking? I am checking whether this 5 is greater than this 1 or not. If this 5 is greater than this 1, then it means that definitely they have an overlapping, correct? So it means that the start of the existing interval, if it is lesser than or equal to the end of the new interval, then what do it means? It means that they have overlapping. So what do we have to do? We have to find the new interval. So what would be our new interval? Our new interval would be the minimum of the intervals, the existing intervals start and the new intervals start, correct? So what this would be? This would be our new intervals start. Now what do we need to find? We need to find the new intervals end. So what would be the new intervals end? The new intervals end would be the max of the existing intervals end and new intervals end, correct? So once we have found out this new interval, what we have to do, we will simply increment the index and we will be in this while loop until and unless this case hold. Why? Because what we discussed in the second case. In the second case, we discussed that this new interval may have an overlap with an existing interval. And after merging these two intervals, the new interval that we can get can again have an overlapping with another existing interval, right? That's the reason why we have written this while loop. Now, the moment we will come out of this while loop, what we will do? We will simply say that answer dot pushback the new interval, correct? Because once we'll come out of this while loop, what does it mean? It means that we are done processing or we are done finding the overlappings and creation of the new interval. So we will simply add the new interval. Now, once we have added the new interval, what we need to do? We will simply keep on adding the rest of the intervals because it is for sure that this interval is not having anything in common with any other intervals. Why? Because once we come out of this while loop, it means that it won't have anything in common with any of the other remaining intervals. So what we'll do, we'll simply keep on adding the remaining intervals. So answer dot pushback intervals index, correct? And what we'll do is simply increment the index. And finally, we are going to return this answer. So let's run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the given 2D vector, that is this intervals, then the total time complexity would be order of n. Why? Because we saw that in the dry run, what we are doing, we are simply iterating over all the intervals present in this intervals vector, correct? That is in this interval 2D vector, right? So we would be processing all the n intervals present in this interval 2D vector, correct? So that's the reason why our time complexity is order of n. And the space complexity is order of 1. Why? Because we are not using any extra space, correct? We are only using this 2D vector to store answer, and because we are supposed to return this 2D vector, so it doesn't get counted as an extra space, correct? So the space complexity would be order of 1. So that's all about today's daily LeetCode challenge. Thank you.